Hello guys. So you are in the test station. No, we have a small group here, and it's gonna be softwares on the screen. So I will just share my screen of the computer. Okay. Ivan, they are asking in which planner you are. It's a joke. Okay, let's share the screen. Let's go. Where is the presentation? So they asked. Some people here already tried a few years ago one of the laser cut and say, "Hey, we didn't care about curve. We don't know what is curve, and it still works." Yes. No. It works because of the material. You cut it 4 millimeter, no?
Yeah.
Okay, the 4 millimeter you cut it is not 4 millimeter, it's 4.2.
Oh.
Okay, so that's why like you got lucky. We know and we can actually account on that. The only way to know how the material is thickness, especially wood. Wood is a really life-changing material. Depends in summer, depends on winter, humidity of the air, like station when the wood was manufactured. It changes with a lot of parameters. So the only way to know is you take a digital caliper and you measure. Actually, if you want to manufacture something in a safe-proof way that one shot and everything works, the only way is take a caliper, a digital caliper, and measure on, depends on the material size, but on the four corners, and you make the average. For example, in the CNC, what we do is we measure 6-8 times if you want to do what. You measure one corner, middle, one corner, middle, one corner, middle, one corner, and you do the average. Or usually what you do is either you take closer to the bigger number than the smaller one. Because the bigger number will have more problems to actually fit. For example, this is a press fit. You see, it's pressed and it fits. But disconnect. And this is cardboard. That is the cheapest material ever. For example, as far as I remember, this is a 4 millimeter joint, and this cardboard is 5. So the press fit in this case is negative. So actually, you make them fit, and you need to press it. This is not glued, and we cannot even take it out. Once you put in, it's really difficult to take it out without actually destroying it. Fab. Yeah. Okay, log out. Look, let's go. So you are here, and you say fab. It's the same username as password. Like NSA proof password. Okay, so this station, we will go a little bit of different design softwares and things that we can do. So let's go over the easiest ones. So first, when you cut on the laser cutter, a lot of people want to cut text. You have a problem with text. That, for example, as simple as this. You have entered your text. When you cut the O, the center of the O doesn't stay in place. I will draw it here. So, for example, we want to, this is the O. We want to do a 0. If you laser cut this, what are you getting? A circle. What you want to make the O is actually to have also the internal circle inside, keep in place. So there are some typos that are like laser safe. What is a laser safe typo? This could be done more or less, depends on the typo, but they make connections on the inner holes, so actually you get the O. So the middle part of the text is held in place. So for example, Stencil, this page, all these links are in the Academy page, okay? Let's go over them. Academy, I have the shortcut here. Weekly classes. Computer control is cutting here. So after the how to cut pasta on the laser cut, we have not only the YouTube tutorials, but also the text tutorials, like extended on each one of them, like short, long guides, how to turn off each machine. Ooh, ooh, what my computer is doing. And for example, how to use a caliper. Do you know how to use a caliper? Okay, good.
I don't. I don't.
So vernier calipers have different measures, and if you don't have a digital one that are like really dumb to use, they have on-off button and zero. Manual ones are slightly more tricky, but they are as accurate as a digital one if you know how to read it, because all these lines are multipliers, and actually they also tell you like 0.000 if you read them properly. They are not only like 1.2, they are 1.23, 1.27. They can measure really well. So these ones are like, if you buy one good one, it lasts for all your life, unless you drop it from an airplane. Or different softwares and multiple tools that are good to use. So let's first go for the stencil. In this case, it will make laser safe text, and it will give us the text in an SVG file. So for example, we have hello, hello, this is a text. I will choose, of course, we cannot make all the fonts laser safe and doesn't have all the options, but at least we have something, or we can upload from font. Not all fonts works. Let's choose Roboto and Stencify. So it will produce the text in a laser safe way. That is quite important. And there are already fonts that you can install in your computer that kind of do this. They are not that common, but they exist. Where to look for those fonts, for example? You can go to that font. Like font library that has millions of fonts. They are not laser safe, but you will need to look for the ones that are laser safe. Here you can choose, for example, I don't know, they have bitmap ones. They don't have a specific category for laser safe, so you will need to look for it. And this library is huge. So unless you want a really specific one, I recommend you to use Stencify. It makes the work and it's super easy and fast. And you can export the SVG formats for the laser cutter or the vinyl cutter. This each station will explain you specifically, but for example, the Roland SRM, the one that Santi is explaining, the big vinyl cutter, is quite old. It's like right now it's like 8, 9 years old, and only reads Illustrator 5 or 6 format. So when you save in Illustrator, save in the oldest format that you can save. In case of the Cameo, it reads SVGs and JPEGs and images. It has no problem with the images, but reads SVGs. In case of the laser cutter, we use Rhino for sending files, so just save in a Rhino open format, like could be Rhino, DXF, or any 2D format.
Do you use SVG to all the machines, or the Roland only because it's
SVG depends on the SVG format. The Roland, the Cut Studio, the software of the Roland, it's slightly weird in the format. Sometimes depends on the program that you export and how you compile the format. So that's I remember that Illustrator 5 opens up. SVG, I don't know if it opens up. Even so, there are plugins for Inkscape for controlling the vinyl cutters directly from your program. So if you have Inkscape, you install the plugin. It's on the Academy. Here are the plugins. I don't know where, but it's around here. Inkscape for Cameo, Inkscape for the other one. You can use it as a printer. They will show up as a normal printer on your computer, like paper printer.
I don't Illustrator. I use a specific typography that I can download it from my phone or whatever, and then I print it with a laser, but the laser opens the file and then it doesn't have that typography. I should save it as a PDF.
No, you need to control your fonts.
Okay.
Fonts are like specific format, and each program opens the fonts based on your computer library font. So what you need to do is you contour, you trace your images. It means you need to vectorize them. Your images. You need to vectorize your fonts. How we do that? I will do it with Illustrator, but you can do it with Inkscape. It's the same. I can have all the software installed in the computer.
And that Stencil, I can download them to Rhino.
It's an SVG standard file, so it will open up. So, for example, I'm making a new file. I have my text. Hello, this is a test. I will make it large. This font right now, if you save it in Rhino, it will not show up. So what you need to do is create outlines or vectorize. Depends on the program. They could call it differently. So you vectorize, and even so, remember to always ungroup your things. So we ungroup, and we release the compound path in general. And you make only vectors. So you don't use the hatches unless you want to use a raster. If you want to rasterize it, like carve everything, engrave, mark everything. If you just want the lines or cut, you need to release the compound path and transform it into a vector. Before it was a like infill layer.
And then you just switch
From fill to only vector drawing. The thickness will not change anything because it's a vector. The thickness is just visual. It's not the laser size. What else we have? More tools. We have box spy, for example. Let's say you want to create a box for your project. Please don't, but maybe you want to create a box for storing your tools. This actually allows you to create boxes based on a specific settings. For example, I want the inner height of the box, like the internal dimensions, to be 50. The width of the card is 50, card height is 50, and I want 2 compartments. I'm using 3.2 millimeter wood because I've measured with the caliper, and it generates my box. So if you want to create this kind of simple geometries, don't break your mind. There are kind of scripts that they do all type of boxes and geometries. I love one that is called Maker Case because it's visual. If it's just a square box, this one is better. Yeah.
I had a program
So
with that.
they show you like the inches, millimeters, for example, 50 or 500 and they will actually show the properties of the box. Why my computer is doing this? 1 second. Guys, I stopped sharing the screen on second. It's doing weird things. Share screen. Okay, now seems better. Not really. Okay. What else we have? We have P boxes, Maker Case. We have the font. This is the presentation. Template Maker. This is for paper crafting in the laser cut. So we have, for example, you want to do an elliptical box. Simple geometries. You set up the units and you just create it. And downloads automatically the PDF. These PDFs are vector PDF. PDF can store different things. One of the particular PDF format, it can store vectors, images, or pixels. And that a document is in PDF doesn't mean that it's a pixel-based or is vector-based. Depends on the program that is actually compiling the PDF. So in this case, that the export to PDF, we can open the PDF in Illustrator, and it will show up as an vector that we could then save to as SVG or a Rhino or a DXF file. They do as a PDF because not everybody is a designer and doesn't know what even a SVG file is. It's quite good and works really well for paper crafting. It means like lower than 1 millimeter thick materials and easily bendable, and has a lot of origami geometries. It's quite cool. If you want to make a coffee, I don't know why, but some people like. Like here we have seen people creating an actual real size coffee.
And will this translate with cardboard or not?
Depends on the thickness of the cardboard and the size of your model. For example, if your box is in cardboard but it's half-meter design, the cardboard bends at that scale. If you're using this cardboard but you're missing a box of 1 centimeter, it doesn't. So it really depends on the scale of relationship between thickness and size of your designs. If you are more interested into origamis, we have the Origami Simulator. Yes. Let me hide this. Hide it so the meeting panels. So the Origami Simulator allows you to import your SVG files. It means your design, and it does in a really particular way. Let's go and show you the example. So we have flapping bird origami, or let's do a simple one. Tessellation Miura, this one? Yes. So based on a specific pattern, what is the pattern and how to draw the pattern? This, in this case, is quite simple, more or less. It's a simple geometry. How the program can know the creases and valleys. What is up, what is down. It does it by a it's red and blue colors. So blue, as far as I remember, is valleys, and red are creases, and black is outer lines. Record animation, save the pattern and SVG. Let's save this one and let's open it. Open with Firefox. Yep, yeah, exactly. So you make a SVG vector file, and each line has a different color. Red is for valleys, blue is for valleys, red is for creases, and black is the counter line. You can input your file, import it, and you can record it, save simulation as an STL. Also, you can save the fixed model. And the good point is you can see how, or the program will try to calculate if it's bendable or not, depends on the geometry, how your model is gonna bend. And also the constraints, like where your paper is also suffering most, the zones that your paper is suffering most. Has by defect lot of examples. It's quite good to understand origami that sometimes it's not that easy to understand. And the simulation is super cool.
Looking at the order in which the folders can see the values in
The order, I haven't went that deep into the program, I have to be honest.
But then, so you fold it manually. It gives you a pattern that you fold manually.
So why we use this kind of things, for example? This, what you do is you laser cut the exterior one. But in case you use cardboard, what you can do is engrave the line. And you can engrave, for example, blue lines with a continuous line and red with some dots. That will weaken up a little bit your cardboard, and you will still need to do the folding manually. When you have make all the folds, that in this case is going to be a little bit annoying, you can then start like doing the real origami.
And if it were like a relatively reduced panel and you calculate it, you would need to do it, right? To do the...
In that case, I will go for cutting through with a dash pattern. Is, for example, with polypropylene, the thin plastic that is semi-translucent. Yeah, usually what you do is like make a lot of dots really close to each other, so actually you weaken the structure of the.
But so that it folds one side and then to the other side.
It will fold for both sides once you. What else we have? And this is more related to CNC, but we can apply more or less also, like the curve, for example, is the curve radius and how the wood will bend based on the curve and the spacing. You can see here that the material is not cutting through, but if you make the design for laser cut curve, the spacing of the lines will still do the same or really similar. So you can actually calculate the radius of curvature that you can bend your wood. With wood, it depends a lot, the type of wood. For example, we have one type of plywood that is bendable plywood that we can make perfect circles with it of 100 millimeter radius. So also depends on the wood. For example, if you make it wet completely, you dip it completely in water for 1 day, it becomes super flexible. It's not the same that is when it's dry. So these are helps to allow you to calculate and test. What else we have? In case you don't want to install Inkscape or Illustrator and you still want to do some SVGs, app diagrams allows you to make diagrams and drawings, but we can always export SVG files that are vector files that will allow us to cut. This is an online Illustrator kind of program. I have like a lot of, it's not a dedicated program, but works well for making diagrams or simple drawings. Then these are examples of cardboard ideas. We always try to push you to try to use cardboard because it's easily recyclable, and you know the house will produce a lot of waste, so we try to keep it as low as possible. Cardboard ideas that maybe you can test that are really good. At home, I had a stool that was made of cardboard for like 3 years, working stool. Yeah. This exactly, it was even thinner cardboard than this. It was craft. Let me look for it. Laser. Well, this one was super cool. Actually, it was 2 models. Is the internal, the core was making a stool for the other one, and it's glued with double-sided tape, not even glue, like ultra lazy. This is honeycomb cardboard, 5 mil, and really good if you don't want to go to IKEA. Holds really well. Passive speaker for the phone. Actually, this is using the one of the pages of that has the predefined boxes, but you also hit a premit and then adding a hole in the box. For example, in this case, that this cardboard is slightly thicker. This is craft cardboard that is slightly more dense and more resistant. Instead of using engraving, you see that we cut through to make the dots, so it bends easily. And what else? Stand-up lamp. I don't have pictures of this one. Cardboard tea table. Ooh, this one is nice. This is assembling. Yeah. Of course, you cannot sit in this table, but it's a small table. Cardboard box lamp. This is so silly, but for example, how to make small, simple lamps with acrylic, some LEDs, and the same with different shapes. It's acrylic just to stick to the. Yeah. What else? This one. Cardboard chair. I don't have the. This is cool. It's called different. Actually, this tool, for example, was modeled like a egg, and then I 3D scan my butt, and I erase subtracted from the egg, and it's waffles. Yes, exactly. Yeah, it's quite comfortable. More cardboard things like lamp, for example, this is stacking really good. If you have like a wavy big pattern of cardboard, produce really nice shadows. Bending, like slightly more complex. Well, if you want to look for more reference, I can give you 1,000 simple lamps. In here, for example, this program has been, this one, they use Slicer Fusion 360. I know because of the tag naming, they does like that. And this is one of the programs that we're going to show you now. Pepakura. Pepakura is super cool. Is actually a lot of people that does like anime, and you know the people that dress up as like anime and they make their own suits. Like more, you will know better. They use this software because it's super good. In Korea, I know a lot of these people that they go to Comic Cons and they make halo suits, and what they do is one guy, the guys that like what making like crazy best did always manually. When he discovered the laser cut, he like increased it by 10 his production. It was crazy. Then he started like making suits every week, one different suit.
I always thought about one of my friends who I just got to the Comic Con and like people started hiring me, and I was like, if I could do this, I like to do so much. I think it's so many.
So Pepakura, the good point is give you unfoldings or really, really complex geometries.
Oh my god.
No, it's great. Like the ones that you buy and they make, it's super good, super good. This is a licensed software, but we haven't installed in the lab computers, the full license. Well, it's still a license, like 20 euros, deserve the price. Like some things are like, a software that is gonna, in case you don't know how to 3D model and you really want to still do complex things, sometimes happen. This software, if you are completely fresh to 3D modeling, might be really good for you, because for people that knows how to 3D model, it's, sorry, but a pain in the ass. I haven't seen any program that has a interaction like moving, zooming, orbiting like this one. So if you are fresh, you still need to learn how to move. So it's the best. But if you know how to move in like normal 3D modeling programs, it's annoying because it doesn't move like any other program, and it's difficult to move. If you don't want to make accurate things, yes. No, accurate thing, it means like, I know that this is measures exactly 10.5 and this measures like 2.5 and it's a distance of like a radius of this of 5 millimeters. But I will, this is the example video and we will do something together. So you see that it's drawing like in the air, because actually it's drawing like that. You just draw with your mouse and creates the shape. Based on, yes, exactly, it's the same. So right now he just put in the direction that wants to create a new part and draws it, creates, draws it, and adapts the shape. Now the next one, and the next one. Now you have this that is like multiplying, create grids, etc., revolve. And you can create a lot of press fits, organic press fits really easily. Yeah, this is like doing this in Grasshopper, like having automatically adapting the rib size for creating this shape is like doing 1 hour script. This one is 2 clicks. SVG. gives you the cutting plans directly, and has, for example, this like interpolate shapes. And the best point is, sorry, it has structural analysis physics, so it will show you where are the weak points of your model and what are you going to break. Yeah, it's surprisingly, I always recommend every year, but I always like model something really basic because it's annoying for me, super annoying to use it, but it's really powerful.
But so how does it,
And it's free.
how does it calculate the measurements? Like basically if I draw it, do I then?
Yeah, you don't measure, that's the point.
So
Yeah.
if I wanted the scale to be 10 inches, how would I?
Let's switch on the software. So for example, I don't exactly control the software, I have to be honest, but what is Flatpak? Flatpak.
You have to download it. Yeah.
No, it's not online, but it's free. So we start with this empty. So let's draw. Edit, snap to major axis, and for example, and now the point is how to move and rotate is weird. It's shift right, shift. Oh my god, it's super. It's so annoying, this thing. The mouse is opposite, so now that I have like the first slice, for example, I can copy it, duplicate this one, duplicate, and I'm going to transform it and move it, and I'm going to scale it like that. And for example, let's interpolate and create the rest of the class. So it's in generate are like the scripting tools. So it's interpolate, slices, branching, grid, blend operation. So if we select one, we blend, select the base sections, 1 and 2, and it doesn't blend. I'm missing a third one to act as a line, as a guide. So let's draw one. So I'm gonna put the drawing direction. That is not this one. This is the annoying part. How to create? Yes, always draw the surface. Oh my god. For example, we have drawn this one. For me, I find it so annoying. If you haven't used any software, it's super cool. Oh my god, the view. Okay, now I have centered view. Now I will edit this. Transform. Let's just make it. Transform. Okay, now we can go to blend. That is blend. We have the base section. Now we have the two other ones. Or instead of doing that, let's move this section. Yes, you can just delete that. Generate, blend by base section, first section, second section. Okay, done. Enter. So now let's say we want to put spikes on them. I want to draw on the surface, perpendicular to the surface, and I want that it creates this shape. Yeah, not really good one. You see, this is the most annoying part for me. Okay, this shape is what we got. ISO. Okay, we have this one, and we want to generate a revolve around it. Select the best section, select what we want to revolve. And we just increase the count. Done. And we can keep going like this and this to create more complex models. On the physics simulation, for example, we can view what is the stability, where this program thinks or model will land on the floor, and how it will land on the floor. What is going to be the support, the connectivity. For the physics, we can put some weight. I will add a weight of 10 kilos. I don't, it's in kilos. Add a weight here, if it allows me to draw a weight.
And now with weight, this ability is assumed that this material is cardboard, or can you change the type of material?
The type of material, I don't know,
Because
to be honest. I don't know.
the stability and strength will depend on the material.
I have no idea. I haven't went that far in the software. Like I'm getting nervous just with 5 minutes. I suppose the engine generator is not like super.
You know the feeling you feel right now with Java? That's what I feel when I'm trying to understand Java.
I suppose. I suppose.
I love you right now.
Actually, you have the density of the material here. Look, the physical value.
So I have to know, like, what is cardboard system?
Exactly. Okay, more software. Easier to use. For nesting, I will say that is 101, mandatory to know these programs. Nesting.
This is how you organize.
Yes. So we have SVG Nest, that is the online version, is older one, but still works well. And you can try it online and you upload your SVGs. Or you can download the newer version that is super cool. It's super easy and super small program. It's called Deep Nest. You will see. So, lo important SVG. In the SVG you import, you need to have also the size of your material, like a square with the size of your material. Let's say I want to input this robot. Okay, I have all these parts and I have my material. I state which one is my material. This one. Sheet 1, I can select it and it will show in blue. And you have configuration things. For example, I want to keep 2 millimeters between the parts because I don't want that the first move when I want, or I want to double cut, or I want to curve tolerance, or I want to rotate the parts. Maybe some parts, because you have a wood grain, you don't want to rotate them. You want to keep them like that. The rotations is weird. For example, it's 4 rotations. That means if we divide 360 between 4, is rotations of 360 degrees divided by 4 rotation, 90 degrees. We can rotate the piece 90 degrees only. If we introduce 8 degrees, 8 rotations, we can rotate at 45 degrees. It means it will try to rotate the parts on 45 degrees rotations. Optimization, we want to fit them on the left, on the top, or just to have the minimum footprint. Like, it has a lot of options. The good point also why I explained the downloaded one and not the online one is because the downloaded one has this kind of side explanation that the online one doesn't have. And it does it also better. This program works is recursive and generative population. That means it calculates one solution. No, actually it does different ways. For calculating is the program tries once, tries 10 times, and see which one is more optimum. Once selects the best one, does the same, trying new or closed approximations from that solution. So every time it's calculating, it's improving itself. It's recursivity calculations based on a base population. You can also change this if you know the meta heuristics a little bit, but you don't need to change anything. You just click.
Again, I do my file, right? I save it as a SVG and write open this program and I arrange it in the type of a page for the material I am thinking, right?
Let's do it since the beginning. Okay. Select all, erase.
I don't know, I don't understand why they, I thought we already done or in the figure.
This, the size of the page.
And arranging it in the page. No?
Okay, will you do this? Lemais, it's not optimized. Will you do this? I have these parts. You will try to match the parts as best as you can. No? Okay. This is my material. I choose it, click calculate.
Way more intelligent than
It's doing around, depends on you calculated around 5 times, 10 by 10. It's gonna do like at least 10,000 interactions and combinations. That's optimization, actually. And you have software for it. Like, don't try to mess around. And you see, it's showing you right now the 4 base case scenarios that it has calculated up to now. Of course, with this, we have always the human factor that I will say that this, even if in square millimeters is more optimal, I will prefer to cut this one because I can have a space left over here. Yes, exactly. So basically, this keeps calculating until you say stop. It's good for me. You stop and you export SVG or DXF. Okay, and last but not least, slicer. This is for, I want to say, waffling structures. In this case, you work with a 3D model. I have downloaded desktop. What is my bunny? I have a bunny that I can set up first. Within this step is the material size. Material, what is the material dimensions we have? And we can select, for example, we have, I don't know, big material, carbon laser cutting. I have made my material by customizing the parameters. It's a medium-sized laser with a 4mm carbon. Okay, based on that, what I want to do? I want to stack my slices, and it will give me automatically the cutouts with the numbers based on my technique. I can choose where is the slice direction. If I'm cutting my bunny, wait, sometimes, yes, is Fusion has embedded this software. If you don't have Fusion, you can also download as a standalone. So you can choose the cutting direction.
And did you, the one who was imported as a mesh?
STL, yes, closed STL or BJ. You can interlock, for example, have a waffle of the bunny. With waffle structure, you have a thing that is sometimes the slice could not be assembled or it's going to be in the air. For example, this one is not attached to anything. So it's warning you, like this is in the air, red cannot be assembled. It's impossible to assemble the geometry. So there is where you actually start changing both the slice direction. Not only works aesthetically, but also maybe a combination that works better. And also maybe we can modify the form by choosing this slice and moving it a little bit. You just move a little bit to make it match.
And so the goal is not to have any use for that.
Yes. So we have assembly steps, and this is crazy. This bunny is simple, but some things are really complex. It will give you how you need to assemble your model to make it fit at first. It's crazy, and gives you the plans and what is the format that you want to export it.
Is there another physics engine to help us figure out, based on where the load is coming from, how we need to?
No, it doesn't have. Maybe
That's not help us. Like we know your butt is declining in normal force.
yeah, that's up to you completely. For example, the assembly steps, you can also choose a little bit of visualization between wood, cardboard, and plastic, fluoplastic.
So that's why we're gonna nest and arrange it.
It's already nested.
Oh.
Yeah, but if you want to optimize it, recommend imported and nested. But a predefined nesting is done and tell you the amount of parts you have and the amount of layers of materials that you need. We have also folded parallels, that is like the kind of prepakura. In this case, only the blue can be assembled. We will need to change and tweak what is the kind of joinery of the paper folding, etc., to make it fit, or 3D slices that is only useful if you 3D print, but not good. Well, give you several options for interlocking things. I like this one, usually slice, interlocked slices, stacked slices, curved slices is this one. That in this case we don't see it really well. Slice direction. The folding is called folded panels. So it gives you different options. What else? I'm missing something. No, I don't think so.
Which was the other option? Was nest?
SVG nest,
And the other option? Deep nest.
deep nest. Here, both are here, somewhere around.
Those guys are really good.
Yeah.
Too much.
Actually, if you go to SVG nest on the bottom, it recommends you deep nest. It's the same guy. Okay,
We're done.
done. Now it's not a station.
Thank you.
No pause.
Thank you. I was already forget everything.
Yeah. That's why everything is documented on the page.
Can I ask you a question?
Yeah.
Two questions. Do our staff have any projects to have?
You don't have a Java Academy project first.
Okay. That's important.
Yes, important.
Okay. Yeah. Okay. And then the second one would be, what's your experience in studying biomaterials? We were discussing this.
I was wondering,
Consistency is a problem. The rest they got well in general. Like any.
but for example, like the painting, of course, the material, the heat, like is it a problem with production and machines and
No, in general, no. Depends on what is the material.
Yeah.
For example, mushrooms, we try not to cut. Like the spores gets everywhere, and
Yeah.
we don't want to grow mushrooms in the electronic boards of the machine. But
But
huh?
I feel like there was some basic.
But
Ah,
I
it's
think
easy to
the laser would melt the jelly.
it melts actually. That's how the laser cuts. Melting things. You need to cut. You need to set up the values correctly. Some materials are really, really fine. You need to find the sweet spot. For example, we have engraved gelatin-based materials, and you can engrave it. It's not consistent engraving, but you can engrave, for example, and cut it too. They don't cut specifically well, but
Yes, we were up and down the 3D model.
oh,
No. Impossible. No, model.
ask Anastasia. For fabrics, ask Anastasia. Yeah, I have literally no idea of textiles.
Okay. No, I had this the other day. I asked you about making human. I downloaded it, and the thing is the model. I don't know if it's on there or I don't know.
This is make human, no?
See, I put also it in Rhino, but the thing is like it says le guarda la ropa completa. Y yo quiero como el cuerpo y la ropa abajo.
No idea. I don't know. Like Anastasia works for Anastasia, make human is like for me right now.
See?
Yeah.
Okay.
Okay, next station.
Cool.
I have more questions?
I have a question with
Yeah.
the blender, because I tried to do the tea yesterday, but I cannot, I don't know, I like. So, it's supposed to be like different section of the tea that I do. But I don't know, I think
This is an animation, no?
yes, exactly. But I don't because I just followed like the tutorial, but I don't know what to do that.
You need to assemble frameworks. With all the programs, they don't export that. It's really weird that they export images. And export all the images. You go to Git or Photoshop, and you open and you create a timeline with Photoshop, then you save the.
Like it is, right?
Huh? Right, yeah, but you can do it with video, like I did before.
Okay, thank you.
So now let's see.
Thank you. Too much information. Yes, I think we really need to start like collecting like. Oh, yeah. But Slender, I love animation in general, so I was gonna be excited.
Yeah, you play with it.
What?
Are you play with it?
Yeah, but I just followed like the tutorial. Because we were, I was super scared because I thought we were supposed to modelize our project. So I did like the